Okay, so in the next section, we are going to learn is chapter 4, 3, but instead of now, we're going to factor. So we're going to be learning about what it is to have factors. So in factor form of a quadratic equation is where you end up with, two things that multiply, because that's pretty much what factors are, right? They multiply together to give you, some kind of a result, right? So you're going to see now, instead of like the equation like this, we're going to break it up in pieces and you're going to end up with two that look like, with parentheses. So you have seen certain methods, right? Probably even since middle school on how to factor. And one of the main ones that they teach is the FOIL method. So the FOIL method, you're going to be using the distributive property. And if you kind of remember, but let's just review it again, you also saw it in Algebra 1, but the FOIL method just tells you to how do you multiply these, or how do you take care of this? Well, what you do is you multiply the first times the first, then you do, that's a first, right? So x times x. Then you do the outer ones. So then it's this one, let's see, inners. Oh, outer, I think it's these out here. I'll have to fix my notes. So the outer ones are the ones that are outside. So that would be this part right here. So I just have the wrong letter. This should have been the L up here and the O down here. The inner ones are the inside ones, so that would be -6 times x, so there it is. And the last ones are here and here. So it's -6 is last and -2 is last, you multiply those. So when you're said and done, that way you multiply everything. So this times this times that, this times this times that. Once you do that, you get it all together. So x times x, x squared. -2 times x, -2x. -6 times x, -6x. And -6 times 2, you get a +12. So therefore, you end up with x squared minus, you combine these two, -2x minus 6x is -6x, -8x, I'm sorry, plus 12. So we're going to be looking at the method of factoring to be able to solve these type of problems. So in your 4-3 solving equation, quadratic equations by factoring examples part of the packet, you'll see more explanation of that FOIL method to find roots, solutions, zeros for quadratics. And so just, look at the examples here. This information is also in the few notes that I gave you on the subject. So let's have a look at this, for example. So what they did to solve this particular equation is they factored by finding the greatest common factor. That's what GCF stands for. And so what you do is you look for the number that that they both have in common. For example, a 9 and a 3 have a 3 in common, right? And they also have the y in common. So what they did was they factored out a 3y. So how do you get this back? Well, 3y times 3y is 9y squared. And 3y times 1 is this 3y. Notice how both terms have 3y in them. So now you can take out that 3y. And what are you left with? The 3y plus 1, 3y plus 1. So now, because if you notice, if I multiply this times this times this, distributive property, I could get that the same equation that I had to start with. So now, solve for y. So 3y equal to 0, divide both sides by 3, y equals to 0 is one answer. And over here, you move the 1 over here, becomes -1 divided by 3, so you get the -1/3. So that is one possible way whenever your quadratic only has the squared and then the linear term, and there is you don't see a constant on that side. Same thing here. So look at those practice problems to practice on that. And then to actually factor this type of problem, I'm going to show you some steps because this seems to be an easily factorable type of problem. So I'll go through that when we're doing the practice problems. So go ahead and look at the examples that they give you. And now let's go ahead and see the examples that they give us here. So it says to write a quadratic equation in standard form when they give you the roots. So this is pretty simple. What you need to do is see, because now they gave you the answers, so they tell you what x equals. X equals to 3 and x equals to -5 in this case, and I'll explain that in a bit because I said the opposite of what's here, right? So let's see what actually happens. So here they give you how to do it. The formula is you take the p is one of the roots, the q is the other root, you plug them in. But if you notice, you end up with the opposite. So if they tell you that the root is 3, in the equation, it's going to look like x minus 3. And I'll show you why in just a bit. So let's go ahead and go to one of the examples. So let me just, question number 1. So according to what they're telling me, they are telling me that this quadratic crosses at 3 and it also crosses at -4 if I were to graph it. Well, let's work backwards. I'm going to move this way. So I actually get x minus 3 is equal to 0, right? Here, the same thing. If I move this to that side, I get x plus 4 is equal to, now there's nothing left on this side because this moved. I have a 0 over here. So this is how you get those factors. So the factors of this quadratic used to be these two guys right here. So just think of always taking the opposite. So if this is positive, you're going to go with a -3 here. If this was negative, you're going to have a positive here. Now what I need to do, I'm going to go up here so you can see what I'm doing. X minus 3 multiplied times, because remember, these are factors. Things that multiply together equal to 0. When I multiply that out, that gives me the answer to what quadratic they were talking about here. So here's what we do FOIL. I do a modified FOIL. What I like to do is just mark it and say, look, XX. Whoa, let's get, I got the wrong pen. Let's get one that's not so cutesy. So x times x is x squared. And then you look at the next factor. I'm going to multiply x times that number. So that 4 times x is positive 4x. Then I'm going to multiply this guy by this guy. And so that gives me a -3x, and the -3 times the 4, -12. So I do FOIL, but not in that order. But it just helps me. That way I go this times this, this times this, this times this, this times this. That way I make sure I don't miss any of the multiplication. So now I have x squared, 4x minus 3x. This I can add them together. 4 minus 3 is 1, so I get plus 1x. And remember, if it's a 1, you don't have to, it's an imaginary, you can, you know it's there, but you don't have to write it. And then I have minus 12, so minus 12. So the question was, write a quadratic in standard form. So I believe that's what I've done, because the x squared first, then the linear term, then your constant. So let me make some room here so I can write my answer. So the correct answer for this one should be y equals, or you can leave it the way I have it here with the 0, x squared plus x minus 12. That was a quadratic that those roots came from. So you're kind of working backwards. Then you're going to work some other type of problems. Here, they want you to solve it by factoring. So we'll go ahead and do, I'll do one of them for you, and then you can continue with the rest. Some of these are kind of like what we saw earlier. So let's look at number 1. Number 1, if you notice, what do these two parts have in common? What do these two terms have in common? I see that they both have a 2 and an x, because if I pull that out, I can multiply 3x, because 2 times 3 is 6, and x times x is x squared. Then minus, well, 2x is already 2x, and the so just -1 here, that should equal to 0. So what are my answers? Well, remember, to make this thing equal to 0, either this part is equal to 0 or this part is equal to 0. Why? Because think about it. If this is 0, 0 times 3x minus 1 is 0. Or if this inside here is 0, then 2x times 0, you get 0. So you break these up into two pieces. Either 2x is equal to 0 And so therefore, I divide both sides by 2. X is equal to 0. Or the other possibility is 3x minus 1 is equal to 0. So move the 1 over, comes over here. So 3x is equal to 1. Divide both sides by 3. So x can also equal to 1/3. So those are my solutions. Those are the two roots. It crosses at 0 and 1/3. So now let me try something like number 7. Number 7, it says by factoring. Well, I look at each of these pieces, and this doesn't have an x. This doesn't even have the number's 1, the number's 1. So I don't think that method's going to work for me like I just did. So let's try the parentheses approach. So are there two things that multiply that give me back this thing right here? All right, so this is the process. You always look at your first term. How can I get an x squared? There's only pretty much one way, right? Well, especially for factoring here, x times x. So you write your x's, because I know that x times x gives me x squared. Then I ask myself, how do I get a negative 30? So I write all the possibilities of getting a negative 30. What I do is I like to start with the 1, then 2, then 3, and keep going until you get all your factors. If I have a negative 1 times 30, that does it. Negative 2 times 15, that'll do it. Negative 3 times 10, that'll do it. And I can 4, 5, I can keep going. But let's go the 4, and it doesn't go evenly. 5 does. Negative 5 times 6. Oh, wait a minute. I think I'm going to stop here, and let me tell you why. Once you find all the factors, all the things that multiply, see, this is times, right? Multiply, multiply, multiply to give you negative 30. Then you find a couple of these that when you add them equal to the number that's there, the number 1. So if I were to take 6 minus 5, how much do I get? 1. So this is the number, the pair, the number that I'm looking for. So 1 is going to be negative 5. 1 is going to be positive 6. Now, how do I know that that's going to work? Well, let me show you. You could always go back and check yourself, see if what you did pans out. So, observe. Let me go backwards now. Now that I have that, and I'm just going to use the space up here, I think these are my factors. Let's test it out by doing now the FOIL to see if it is true. X times x, x squared. X times 6, positive 6x. Negative 5 times x, negative 5x. And negative 5 times 6 is negative 30. I combine like terms. 6x minus 5x is positive x minus 30. And voila, it looks exactly like that. So yes, I just found the factors for that particular equation. This is going to take some practice. Look over my video again, and I think you'll get the hang of it once you practice some. And so same thing, you're going to be given the roots, factor the polynomial, so factoring here, practice, and again solve by factoring. Let me do one more just to show you the method. So if I'm going to factor, let's see if we can find the factors quickly. First, you ask yourself, okay, how do I get x squared? X times x. So you write that down. How do I get this number? So negative 12. Let's find all the ways. Negative 1 times 12, negative 2 times 6, negative 3 times 4, negative 4 times 3, negative 6 times 2, and then 7 doesn't work, 8, 9, 10, 11, and then back to now negative 12 and positive 1. See how these are different? When it's the negative on one number, and then it will give you a different answer. Why? Now I have to add them. So let's try to find a pair. When I add them, I get a negative 4. So let's go through the list, and I kind of automatically am kind of looking at this because I know that negative 6 plus 2 So if I have 6 negatives, I have to take away the 2 because it's a different sign. So I end up with -4. So bingo, this is the factors that I'm going to be using. So one here has to be -6. The other one has to be +2. Notice how this wouldn't have worked, because if I had used that, what is 6 minus 2? I get a 4, but I need a -4. So that's kind of the reason I know that wouldn't have worked, and that is equal to 0. I've done my factoring. So again, go through the steps and hopefully you'll be successful.